Hi, everybody. All right, so it's time to review for that test. If you have questions about valence electrons or some of the other chemical properties and changes we've gone over, go back and watch my old video. In this video, we're going to talk about chemical bonds. Before we start doing that, we're going to talk about the periodic table. Yes. All right, so the periodic table is organized into groups. Here's group 1, group 2, Group 3, 4, 5, 6, 7, and 8. Groups are organized into columns. They go up and down. And the important thing to remember is that groups all have the same number of outer shell electrons, or they have the same number of valence electrons. Everything in group 1 has 1 valence electron. Things in group 3 have 3 valence electrons. Things in group 7 have 7 valence electrons. All right, so besides groups, we also have periods. Periods go across the periodic table, across. And periods share the same number of electron shells. Everything in period 1 has 1 electron shell. Everything in period 2 has 2 electron shells. All right, so there's 4 important group names that I would like you to remember. 1 is the alkali metal group. Group 1 is called the alkali metals. Group 2 is called the alkali earth metals. Group 7 is called the halogens. And group 8 is called the noble gases. Those are the 4 groups whose names you need to remember. All right, so the big question, why do atoms bond? Atoms bond because they want a full outer shell. If they have a full outer shell, that makes them stable, and all atoms want to be stable. So to be full means to be stable. Most elements are full if they have 8 electrons in the outer shell. If you're hydrogen or helium, it's just 2. Everyone else wants 8. So one group in the periodic table that doesn't react with anybody is group 8. Group 8 is called the noble gases. The noble gases all have 8 valence electrons because they're in group 8. And since they already have 8 electrons in their outer shell, they're not going to react with anyone. They're full. They're happy. They don't care about anyone else. Look how happy these guys are. They're noble. They're not going to react. So group 8, the noble gases, don't react with anybody. So here's a quick example of a chemical bond. Chlorine has 7 valence electrons. Remember, valence electrons are the electrons on the outside here. 1, 2, 3, 4, 5, 6, 7. It has 7. Chlorine to react, for chlorine to react, it wants 8, so it needs 1 more. Sodium has 1 valence electron. If sodium loses this 1 electron, it'll get 8. So sodium wants to lose 1. So when you mix sodium and chlorine together, they'll react. And what happens is sodium gives up its 1 electron to chlorine. And they'll stick together because they both will be able to fill each other's shells. Sodium gives away its 1 electron, and chlorine accepts it. So what we've done here is create an ion. An ion is when we have an uneven amount of protons and electrons. All of a sudden, there's more electrons than there used to be, or there's less electrons than there used to be. An ion is when there's a charge on an atom. Here we create that ion by giving away an electron for sodium, and we create an ion here for chlorine because it gets an electron. That's what an ion is. It's just an atom with a charge. Okay, so a few new vocab words that are important. Some of them are not so new. We've had them before. A molecule is a group of atoms that's bonded together. It doesn't matter what it is. It's just a group of atoms. Could be the same, could be different, as long as they're bonded together. Then we have a diatomic molecule. A diatomic molecule is made up of only two atoms. Two atoms. And it's two of the same atom. For example, H2, two H's. N2, two N's. Oxygen, O2, two oxygens. Fluorine, two fluorines, F2. So diatomic molecules always have two atoms, and they're always the same atom, like you see in this picture. All right, so besides molecules and diatomic molecules, we also have compounds. And compounds are molecules made up of two or more different elements. So it's not all the same. If it's all the same, it's going to be a molecule. If you have different molecules all stuck together, it becomes a compound, just like this. We would consider this a compound. So when we were answering questions in class, we saw that this was an example of, this was an example of a molecule and a compound. We saw that this was an example of a diatomic molecule. And we saw this was an example of only a molecule because they're all the same. All right. The next important thing that we learned about the periodic table is that we can split it between metals and nonmetals. Metals are on this left side right here. See all these orange elements here like zinc and silver and gold and mercury, cobalt and titanium and calcium and potassium. These are all metals. All metals. Everything on this side here in red is a is a nonmetal. Everything in red is a nonmetal. Oxygen, chlorine, carbon, potassium, these are all nonmetals. Now remember, hydrogen is weird. In the reactions that we're doing, we're going to consider that hydrogen is a nonmetal. We have metals on this side. Hydrogen is a nonmetal. And then nonmetals on this side. Here in between, we have what we call metalloids. We're not going to worry about that. All I want you to know is nonmetals and metals. Now on the test, you will have a periodic table. I'll expect you to know which side is metals and which side is nonmetals. Now, on to the important stuff. We have to talk about the two kinds of bonds we have. The first one is an ionic bond. An ionic bond happens between a metal and a nonmetal. So ionic bonds happen between something from this side and something from this side. In this kind of bond, the metal always loses an electron, and a nonmetal always accepts an electron. See here, we have the metal losing the electron and the nonmetal accepting the electron. It forms an ion, and these two ions will stick together because we have a positive and a negative ion. It pulls them together. That opposite charge forms an attraction. It's why they come together. So here's another example of the same thing. We have sodium losing that one electron and chlorine getting it. Metal loses the electron, non-metal gets it. So, end point, ionic bonds between metals and nonmetals. And then we have covalent bonds. Covalent bonds are bonds between two nonmetals. That means covalent bonds are happening between these red elements. Could be between carbon and oxygen, fluorine and oxygen, sulfur and chlorine, chlorine and bromine, chlorine and fluorine, any of those. Anything that's non-metal coming together, that's a covalent bond. And a covalent bond, in a covalent bond, electrons are shared. They're always shared. See, there's no arrows showing where electrons are going. It's because the electrons are evenly shared between them. Electrons aren't moving elsewhere, they're being shared. So our example here was hydrochloric acid, HCl. See, hydrogen needed one more electron and chlorine needed one more electron. They came together and they shared that. And then we have three different kinds of covalent bonds. If they're sharing one pair of electrons, that's called a single bond, and we draw that with one line. If they're sharing two pairs of electrons, we call that a double bond, and there's two lines. If there are three pairs of electrons being shared, 1, 2, 3, we call that a triple bond, and we draw it with 3 lines. All right, and after that, it was just practice. So, in the words of Shia LaBeouf, yes, you can. You'll do well. Remember to study. Look over your study guide. Watch the videos. I think you guys will do just fine. Good luck studying, everybody.